So this video is going to show you how to run, control the motor and control its speed. It's still going to just be moving in one direction, but now we've got a potentiometer that we can use to vary the speed of the motor. So it's not just full on. If you noticed from your own or from the video that I just showed, this thing spins incredibly fast. Still not able to like really slow it down a lot, but that's partially because there's no load or weight on this motor right now. I put a piece of tape on here so you can see as it spins around. It's a little bit more visible, but really this thing is still spinning around. Even when it's going slowly, it's still spinning around like hundreds of times a second. So the usually when you're using a motor, you will have some sort of load on there, and that'll slow it down. It'll also increase the amount of current that it pulls. So these are just some things to keep in mind. I don't want to get super into motors and the mechanics of them. That's a little bit outside of the scope of this for the time being. I just want to get you up and running, working with them first. So uh, I've changed over to a nano, which most of you are using for the illustration. You can see here, this is the MOSFET right here. I've got, it connected to pin 3, and then I've got the motor right here, and then I'm connecting it to our common ground on this pin. And the other end of the motor is connected to my external power supply. External power supply shares ground with the microcontroller through here. And you'll notice that there's also now this lovely potentiometer on here. So the potentiometer is connected to pin A0, and you'll notice that even though this power supply is 5 volts, I'm still plugging it into the 5 volts from the microcontroller. That's because that there might be some slight differences there in voltage, and this way we can just make sure that we aren't crossing any wires here. So again, keeping the actual power line separate for the components, but having a shared and common ground. Now, the way that we're doing this is we're just going to do an analog write with the motor, and that will allow us to change the speed of it. So 0 is off and 255 is full on. So when we read the value in off of here, we're going to need to reduce that to something between 0 and 255 as opposed to the 0, 10, 23 that we can actually read off of this, right? So you can see here, this is the code. We've got our motor pin on pin 3. We've got a potentiometer on pin A0. The motor speed at first is 0. We set the motor pin up as an output. We don't need to set the analog input pin as an input. It knows that already. And then in the loop, what we do is we read the value off of the potentiometer and we divide it by 4, so that packs into a value between 0 to 255, and we set that to be the motor speed. And we write that out using analog write. So analog write to the motor pin and then the motor speed. And then I just have a slight delay right here. This is not so much for the motor, but it's more for the analog to digital controller on the or analog to digital converter ADC on the potentiometer that the potentiometer is connected to. Now, again, you'll see that this is a little bit of a snake pit of wires. I'm sorry I don't have anything cleaner to show you all, but you can see this is my external power right here. This is the motor and potentiometer. I'm going to pull this in and see if I can get this into a spot that works a little bit better for you all. So you'll see that here's my motor, and I'm going to hold this up and I'm going to turn, where's this knob? There we go. So I'm going to turn this knob real slowly, and you'll see right here, it's in one position, it's not doing anything. And so I'm going to turn it slowly, and what's going to happen is you'll see that it just kind of moved a little bit. Not very much. Oh, and then all of a sudden it just turns on, right? So what's going on is we're overcoming inertia with the motor. And in order to do that, we're going to see, I'm going to ease this back down and see that view that you just saw was an attempt at a slow motion capture of this thing. You'll see that it's still moving really fast. Now you'll see like I get down here and it's still flopping around a little bit. And then, so I still have more to go here to turn down. And if I still have more to turn up before it actually turns on, it's because the motor requires it has to overcome inertia, and that can take a little bit of time and power. So it'll start moving with less power than it takes to actually like get it. So like once it's going, it requires less power, right? Um, so it takes a little bit more to get it over that initial hump, but then once it's going, as long as there's not a lot of torque or pressure on that shaft, it should flow pretty well. So next thing I'll do is I'll show you all how to use an H-bridge, which will allow you to not only move a motor in two directions, but also regulate the speed. It's an external chip. It's a little bit more of a complicated wiring setup, but it works really well. So yeah, we'll move on with that next.